Welcome to this brief educational video where I'll introduce you to SceneScan and guide you through its basic functionality. This video is designed for beginners and marine professionals new to the system and will help you get started with ease. The SceneScan is a laser-based relative position reference system developed by Guidance Marine. While it operates on similar principles to other laser-based systems like SceneScan, FanBeam, and SpotTrack, SceneScan offers a significant advantage. It does not require any target, reflector, or prism to be installed on the structure or vessel being approached or used for station keeping. When approaching a scene, it scans the environment and tracks. SceneScan provides tracking information relative to natural or man-made structures within the sensor field of view. It tracks by matching its current observation of the scene against a map generated from previous observations of the scene. To ensure accurate map generation, the vessel should be stationary before initiating SceneScan tracking. The system works up to 300 meters, but this range can vary based on target's shape, surface reflectivity, and weather. Normal operational range up to 200 meters. SceneScan has built-in gyro, accelerometer, and single-axis gimbal for wave compensation. SceneScan builds a reference map during its first scan, but if the environment changes, like moving vessels or swinging cranes, a remap may be required. In environments with smooth or featureless surfaces, such as open water or plain walls, SceneScan may struggle to track position. It depends on visual contrast and structure detail to stay locked in. Environments with repeating elements, like rows of identical containers, can confuse the system's pattern recognition. Fog, rain, snow, or sea spray can scatter or block the laser beam. Harsh sunlight reflected off shiny surfaces can trick the system into false readings, introducing ghost data into the scan. Heavy vibration can shake the laser, misalign optics, or disrupt data. Vibration-damped mounting is recommended. SceneScan comprises several key components. Rotating laser scanner captures 360-degree environmental data to identify and track surrounding structures. Control PC processes laser data, generating real-time positional information for the DP system. SceneScan client software provides a user interface for monitoring system status, configuring settings, and visualizing tracking data. To start SceneScan dashboard, ensure that the SceneScan sensor is powered on. Double-click on the SceneScan dashboard icon. The dashboard display screen will appear. If the sensor is currently suspended, the main part of the screen will be grayed out. Click on the Resume button in the sidebar in order for the sensor to begin scanning and for the results to be displayed on the screen. If the sensor was already scanning, then the current scene will be displayed. Press Start button. The sensor first calculates the most reliable and informative section of the scene to track off. This step is called tilt optimization and involves the sensor scanning through various sections of the scene to work out which tilt angle to track at. Once a suitable section has been selected, the system starts tracking and reporting the position of the sensor within the scene. As the sensor moves and the view of the scene changes, the sensor will automatically update its model of the scene while tracking without any need for user intervention. Scene reference point is the point within the scene that SceneScan will report its position relative to. By default, SceneScan will select the center of the tracked scene as its scene reference point, with a heading of 0 degrees. This behavior should be sufficient for most users. However, users are also able to edit the scene reference point, altering both its position and heading. This might be done to align to the heading of a tracked vessel or to position oneself against the edge of a platform or quayside. Once tracking, the dashboard will display tracking and scene data, but the sensor will not have the DP feed enabled. The reason for this is to allow the operator to review the detected scene and to set a scene reference point of their choice before enabling DP feeds. Click on Enable DP feeds, accept, and now you can enable the sensor in DP system. The scanner can be operated in auto tilt mode. When starting tracking, the scanner will automatically sweep through a range of angles to determine the most stable scene for tracking purposes. It is highly recommended that auto tilt mode is used to start tracking when using SceneScan. However, if a situation is encountered where tracking performance is unacceptable when using auto tilt mode, then the option is available to manually select a tilt angle. Manual tilt. This mode is used to manually tilt the optics to point at the scene. For example, when station keeping close to a platform where the superstructure is high up and the SceneScan beam must be tilted upwards. When starting tracking, the scanner will initially use the currently selected angle. No sweep will be performed. Manual tilt can also be used to visually survey the scene around the vessel without tracking. Once a suitable tilt angle has been chosen, tracking will start, and the scanner tilt angle will automatically adjust as the range to the asset changes. This is to ensure that the same part of the scene is used throughout the tracking session. Here are some general guidelines to follow when using manual tilt mode. Try to select regions of the scene that have a high level of vertical consistency. If the vessel will be maneuvering around the structure, then consider whether structure on different sides of the structure are also vertically consistent. Watch the screen to see how consistent the image of the structure is before starting tracking. If the scene is changing dramatically, then tracking is unlikely to be stable and a different tilt angle should be chosen. Small tilt angles will generally provide better tracking performance. This is particularly true when the range to the asset will be changing significantly during a tracking session. When tracking off a rig, substructure tends to provide more robust tracking performance than superstructure. Single monopoles, such as wind turbines, are challenging as it is possible to navigate around a monopole at a set distance and notice no difference in the map. When navigating at single monopoles, a different algorithm should be selected, which finds and navigates from the center of the monopole. In the standard SceneScan operating mode, when tracking is commenced, there is a scan angle optimization step that the system runs through. This does not happen in monopole mode. With the monopole system, the user must select an angle which will be clear of the operation that will be taking place whilst on DP. This is because in a typical operation, there is often a structure brought into close proximity to the monopole or turbine, such as a walk-to-work gangway. The monopole mode should only be used when working at scenes where we are only approaching a single monopole structure, such as a wind turbine. For all other asset types, the standard algorithm should be used. To modify the algorithm used by the SceneScan, connect the SceneScan service interface to the sensor. Click on the Parameters tab, then Edit button. Check or uncheck the monopole mode enabled as required. Monopole mode looks for circles in the scene. Under Monopole's configuration, two select boxes are provided where the range of sizes of monopole can be specified. The upper and lower radius limit needs to have the smallest difference as possible while still making sure it covers all target monopoles. Click on Apply to save the changes. To start tracking in monopole mode, click on the Tilt button on the sidebar. Ensure that the manual mode is selected. Manual mode is the default setting in monopole configuration. Click on the plus or minus buttons to adjust the angle. Click on the Apply button to confirm your changes. To commence tracking, press the Start Tracking button. Click on the Apply button. The position of the tracked scene can be displayed as Range, Bearing, and Heading mode. Displays the distance and the bearing of the reference point from the sensor. The radial markers are zeroed in line with the vessel bow, and a magenta tag marks the bearing. A purple tag represents the heading. In A and B axes, the position of the sensor vessel is expressed in meters from the scene along A and B axes, which have their origin at the reference point. The vessel's relative heading is measured clockwise from the A axis. When in monopole mode, the SceneScan tracks the range, bearing, and radius of the monopole. It can also display the bow and starboard axes. In this mode, the position of the sensor vessel is expressed in meters from the target along bow and starboard axes, which have their origin at the target. The B and S coordinate axes are always parallel with the vessel's own axes. There are two types of blanking: static and dynamic. Static blanking zones are used to mask segments of the scan rotation that are obscured by the vessel's superstructure. While the scanner passes through a blanking zone, the laser is switched off to prevent unwanted reflections from interfering with the scene data. To modify static zones, click on the Take Command button. On the Blanking tab, click on the Edit button. Amend the blanking zone. Start and stop fields as necessary. If you wish to delete a zone, set Start and Stop to the same value. Click on Apply to save the changes. The dynamic blanking zone is used to mask a segment of the scan rotation. When the scanner passes through the dynamic blanking zone, the laser is switched off to prevent any unwanted reflections. Minimum blanking zone is 23 and maximum is 327 degrees. Generally, the dynamic blanking zone will not need to be changed. However, there may be occasions when it is necessary to adjust the dynamic blanking zone. For example, to mask out. Other vessels in vicinity, rotating walk-to-work gangway in case it is in field of view, rotating working crane in case it is in field of view, any other massive moving objects on the scene. To mask out unnecessary objects from scene, the range filters can also be used. Any objects at a shorter range than the range threshold will no longer be visible to the sensor and so will be excluded from tracking. The range threshold can be adjusted between 1 and 70 meters. Power controls can be used to set up the transmitting power manually. Maintenance should be carried out as per shown table. Make sure that your SceneScan lens is always clean. That brings us to the end of the video. Thank you for watching. I hope you found it helpful and now feel more confident using SceneScan. Wishing you safe and successful operations at sea.